when you go through and do the quadratic formula, you do end up with a number inside the radical, and that number is called the discriminant. The discriminant is the b squared minus 4ac part of the quadratic formula, and they do want us to go through and calculate that sometimes because it does give you some information about how many solutions you're going to have and what kind of numbers they are going to be. So for example 2, we're going to take a look at finding the type and number of solutions. There is a little table here which lets you know the important things. When we calculate b squared minus 4ac, if you get a positive number, then you end up with 2 real solutions. And they'll be different numbers. They're distinct. So you're going to end up with 2 real number solutions. If you get 0 for your discriminant, when you calculate b squared minus 4ac, if you get 0, then there is only 1 solution, and it's a real number. And if you get a negative number when you calculate b squared minus 4ac, you do get 2 solutions, but they end up being complex numbers instead. Our book says non-real complex solutions. So when we go through and we use that little bit of information to do problems, we are supposed to find the type, which is real or complex, and the number, which is 1 or 2 solutions. So for this problem, in order for you to use the quadratic formula or to find the discriminant, just the b squared minus 4ac part, in order for you to go through and find that, what you do need to do is you need to have this in standard form. And right now that's 6x. That is in the wrong spot. We need to move the 6x from the right side over to the left side, and we want to put that into standard form. So I'm going to list the x squared term first, then the x term, then our number, and then we'll have this equal to 0. Then from there I can identify a, b, and c and plug that into the quadratic formula, or just calculate the discriminant. In this problem, we don't have to do the whole quadratic formula. They're only asking us to calculate the discriminant to determine the type and number of solutions. So a in this problem is 9, b is -6, c is 1. And we want to take that and plug that into b squared minus 4ac. It does not include the square root. It's just b squared minus 4ac. So for this problem, to do b squared minus 4ac, which again, that thing is called the discriminant, b in this problem is a -6, so we're going to have a -6 squared, and then minus 4 times a times c. So for this particular problem, we'd have -6 in parentheses squared, which would give us 36, minus 4 times 9 times 1, which is also 36, so you get 36 minus 36. Your discriminant in this problem is equal to 0. And if you end up with 0 for your discriminant, there is just 1 solution, and it ends up being a real number. So 1 real solution. So those are our 2 answers to this. They asked how many and what type of number. So for this problem, we ended up with 0. When we did the discriminant, that gives us 1 real solution. For letter B, we have 5x squared plus 7 equals 0. We do have it equal to 0, so we don't need to move anything around. A is always the number of x squared, so A is 5. B is the number of x's, and we don't have any, so B in this problem is 0, and C is that positive 7, that constant on the end. So we're ready to calculate the discriminant. That is b squared minus 4ac, and for this problem b is 0, so we would get 0 squared minus 4 times a times c. That would give us 0 squared minus 4 times 5 times 7. 4 times 5 is 20, 20 times 7 is 140, so 0 squared minus 140 is negative 140. That is a negative number. The discriminant is equal to negative 140, but what determines the type and number of solution is whether this number that we calculate, the discriminant, is positive, 0, or negative. So in this problem, we ended up with a negative discriminant. That means that there are going to be 2 solutions, and they are going to be complex numbers. So we end up with negative 140 as part of the answer to this problem. If we need to calculate the discriminant, that's that. And then the type and number of solutions, there are 2 non-real complex solutions. That's the phrase that the book is going to use. So the discriminant itself is equal to negative 140. And what that tells us, using that little table, is that we have two complex number solutions. Technically, two distinct non-real complex solutions, but most people say two complex solutions.